Hi, everybody. This is a little lesson about using the Avogadro's number, molar mass, and a mole to solve dimensional analysis problems. And we'll practice reporting our answers with the proper number of significant figures and reporting answers with the units. So yesterday we established the fact that a mole is equal to 6.022 times 10 to the 23rd particles. That is Avogadro's number. What we call the particles depends on what it is. If it's an element, we call the particles atoms. If it's a compound, we're going to call them molecules or formula units, depending on what type of compound it is. We also practiced learned the fact and then practiced adding them up. The fact that the mole is equal to the molar mass of either the element or the compound. Remember that you find the molar masses by using the atomic masses on the periodic table. And if you have a mole, those numbers are equal to the number of grams then in a mole of that particular substance. So we just have a couple of problems to do. And in every problem, we are going to continue to just use this relationship right here. You'll see this in the bottom of every screen, okay, where a mole is equal to the molar mass and a mole is equal to 6.022 times 10 to the 23rd particles. These are our equalities that we are going to use when we are solving problems with, factor label. So in this particular question, it says how many moles are represented by 125 grams of silicon. This is just like a problem if you have the Christmas tree is 83 inches tall. How many feet is it? You're just doing a conversion. It's still going to be the same amount of silicon. It's just going to be represented in moles instead of grams. So just like the other factor label problems that we learned earlier, we're going to start with the number that we are given, and you should always put a label on it. That is grams of silicon. And then you use these equalities that are listed below to do a conversion. We know that the molar mass in grams is equal to 1 mole. We need to put the grams on silicon on the bottom, the 1 mole of silicon on the top. And when I look on the periodic table, I can see that it is 28.09 grams. You see that by setting it up that way, just like the other factor labels we've done, when you're converting, for example, inches to feet, you would put the 12 inches on the bottom. We put the grams on the bottom so that the units divide out. So we take 125 divided by 28.09, and I'm going to keep 3 sig figs in my answer because 125 has 3 sig figs, and I get 4.45, and the label is moles of silicon. Let's try another problem. What mass in grams is equivalent to 2.50 moles of lead? So in this problem, just like the last one, you start with the number that you're given. And we are starting with 2.50, and that is moles of lead. You want to set up a factor to complete your conversion. We know that 1 mole of lead is equal to the grams of lead on the periodic table. Looking up lead, it is 207.20. I, in this case, will be multiplying so that the moles divide out. I will multiply by the number of grams and get my answer to be 518 grams of lead because I need 3 significant figures. So we are just using these for factor label conversions. When you are setting up these problems, always include labels and let those labels guide you. When you look at this problem, it says determine the mass of 4.25 times 10 to the 21 atoms of silver. So we got to start with the number that we are given. And this is atoms of silver. So remember, you let your labels be the guide. Okay, I'm eventually trying to find the mass. atoms are particles. So first I can use this equality, the bottom one, to convert the atoms into moles. And then I can use this equality to convert the moles into grams. Again, you let your labels be your guide. You have to put the atoms of silver on the bottom so that it will divide out. 6.022 times 10 to the 23rd atoms is equal to 1 mole of silver. And on the bottom, I need Avogadro's number. It's hard to fit everything in, so my apologies. Now, this question doesn't say how many moles, it says determine the mass. So I want these atoms to divide out. Oops, that 10 to the 23 does not divide out, just the atoms, just the label. But now I need to set up a factor so that my moles of silver will also divide out, and I can end up with grams of silver as my answer. That's where this second equality comes in. We know that 1 mole of silver is equal to the molar mass. You get that on the periodic table. I looked that up for silver, and it's 107.87. Decimal here, and then 87. So now the moles of silver will divide out. And if I take 4.25 times 10 to the 21, I want to divide by Avogadro's number, 6.022 times 10 to the 23rd, and multiply by the molar mass, which is 107.87. And I get for this answer, I need 3 sig figs. I get 0.761 grams of silver. I'll just do 2 more problems, because if it's a compound, you do the problems the same way. It's just that you have to add the molar mass instead of just directly looking it up on the periodic table. You need the formula for the compound, and you look up each element and get a grand total so that you have the molar mass for the compound. Like in this problem, it says how many moles are represented by 2.250 times 10 to the 24th. And this is molecules. Oh, wow, I'm having trouble with that. Sorry. Molecules of H2O. And I'm going to just do a little bit of erasing to clean this up, because that does not look like a 4, and that does not look like an H. Hopefully I can get that cleaned up so it looks a little bit better. So 10 to the 24th, and that is molecules of H2O. Okay. I can set up a factor. I can convert from molecules to moles using this bottom number. 6.022 times 10 to the 23rd. And that is molecules of water. That Avogadro's number of molecules is equal to 1 mole. So on the top, I need 1 mole of water. If this problem says how many moles, I'm done. If it says how many grams, I need another step. I look back and I check it out. It says how many moles. So at that point, I'm actually done. I wanted to change colors, get rid of the molecules of water. My answer is going to be moles of water. And I am taking the 2.250 times 10 to the 24th. I'm dividing by Avogadro's number. This has 4 sig figs. That trailing 0 counts because of the decimal. And my answer is then 3.736. This is supposed to be a decimal. Again, clean that up a little bit. Now, I definitely want you to practice this one. This is a decimal right here. Plug that into your calculator and make sure you do that right. There are some calculators out there where you need to put parentheses around this to get the right answer. So practice and make sure you get an answer with the right power of 10. And if you don't, that is something that you want to ask me about. Anytime that Avogadro's number is on the bottom, like here's another one that's at risk for getting the wrong power of 10, you might need to put parentheses around that if you're getting the wrong power of 10. That one's okay. That one's okay. Questions? If you have them about your calculator use, please see me. Now this one says determine the number of carbon dioxide molecules present in 100.0 grams of carbon dioxide. So since this is a compound, we need to know what does carbon dioxide weigh. We've got to do a little side problem down here. We know that we have 1 carbon and 2 oxygen. We look on the periodic table, we see carbon is 12.01. We see that each of the oxygens is 16.00 for a total of 32.00 for the oxygen. Add that up and you get 44.01. This is the number of grams that's equal to 1 mole of carbon dioxide. You have to read the numbers on the periodic table, multiply them by the subscripts, and get a grand total to get the molar mass of a compound. But once we know that, we can do an easy conversion. That tells us, oh my, what a mess. I forgot my good pens tonight, and I'm at home making this. I don't know if you can hear my puppies walking around, but my good pens are at school, so a little harder to write. But we can use this top conversion first in this case. Why? Because we need to go from grams of CO2 to moles of CO2. We know that 1 mole is equal to 44.01 grams. How'd we get that 44.01? That's what this little problem at the bottom was about. Finding the molar mass. Oh my goodness, I just think I'm making it worse. Finding the molar mass of the compound. Let's go back to this. 40. Just resists 44.01. That's what should be in there. There we go. A little bit better. Now you have to look at the problem. If we stop at this point, crossing out the grams of CO2, our answer is going to be moles of CO2. That's not what this problem is asking for. It says determine the number of molecules. So you need another step to convert from moles of CO2 to molecules. And for that, we are again using Avogadro's number. But this time we're putting the moles on the bottom so that the units divide out. See that? And then the units that we have on the top, which is molecules, instead of atoms, this time it's molecules because this is a compound. Molecules of CO2. That unit is going to carry over into our answer because it did not divide out in solving the problem. You'll take 100, divide by 44.01, multiply by Avogadro's number. This has 4 significant figures because trailing zeros count when there's a decimal, and that makes all of them count. And so my final answer is 1.368 times 10 to the 24th, which of course you could use the E as well, times 10 to the 24th molecules of carbon dioxide. So in every problem that you do, you are using these 2 relationships right here and just setting them up so that the labels divide out and you're working towards the label that's being requested in the answer. The conversion factors, these 2 things, they do not limit your sig figs. You always look at the first number right here to determine the sig figs in your answer, and you always set this up so that your units will divide out, and the units on top of the last factor, that's the units or label for your answer. Good luck. I'm sure you'll do fine. You're using factor, label, or dimensional analysis to solve problems with Avogadro's number and molar mass. Just remember to report your answers with the proper number of sig figs and with a unit. Okay? Good luck.